doing? Good day, Algebra. We are kicking off this Monday. It's going to be a big week for you all. This is when, starting with CO40 is when Algebra really ramps up. We are starting our kind of three-part series on what are called systems of equations. Okay? Systems of the equations. What's the problem? And you don't have to write this in your notes if you don't want to, but we're going to kind of define what a system of equations is. What's the problem if I just told you to solve for x and y, given the equation x plus y equals 10? What's the problem with that, Colin? Well, in a sense, tell me what you mean. You don't have enough information.
Well, you can't.
I mean, can you stop?
You can't isolate one or the other. They both are 10.
Okay, so maybe instead of asking what is x and y, I would have to ask what could x and y be? What could x and y be? Nathan?
They could be 3 and 7.
Sure. X could be 3 and y could be 7 because 3 plus 7 equals 10. What else could x and y be?
4 and 6.
Could be 4 and 6 because 4 plus 6 is 10. What else could x and y be? Katie?
6 plus 4.
6 and 4, right? Same numbers, but different solution because in this case, x is 4, y is 6 versus x being 6, y being 4. What else could x and y be?
9 and 1.
9 and 1. Someone get pretty creative here. Think outside the box a little bit. What else could x and y be? Eli?
20 and negative 10.
Sure. 20 and negative 10, right? Because 20 plus negative 10 does equal 10. So back to my original question here. What's the problem with asking you to solve for x and y when I give you the equation x plus y equals 10? There's a ton of different solutions, right? Really an infinite number of solutions, okay? Because you can infinitely pick values for x and then figure out what you have to add to that to get to 10. So what a systems of equations does, let's say this here. What is the value for x and y if x plus y is 10 and x minus y is 4? Okay? This narrows down your number of possible solutions to 1. There's only one value for x and y that when you add them will get you 10, and when you subtract them will get you 4. What is it, Leo? 7 and 3. Okay? The only solution that works here is x is 7 and y equals 3. So what a system of equations is, it is multiple equations with the same value for x and the same value for y. Okay? Which is why the first method that we're going to learn on how to solve these is graphing. Because what do we know about graphing?
They have an x and a y.
They have an x and a y.
You can plus and minus.
Slope, y-intercept, things like that. But when we graph these equations, what are we going to be looking for?
Slope.
Colin.
The intersection.
Right. Where the two lines intersect. Cole, are we looking up here? Okay. Let's take a look at our first system here. We're looking for what's the value for x and the value for y that makes both y equals 1/3 x plus 1 and y equals negative 2x plus 8 true. A little bit more complicated than our first example here, right? This one we were able to kind of solve mentally after talking about it a little bit. This one, good luck solving it mentally. Okay? So let's graph it. Our first one, we'll do it in green here. Y equals 1/3 x plus 1. We've graphed equations before. We know how this works. Y-intercept, positive 1. Slope of 1/3, up 1 over 3. Okay? Now, in the past, when we've graphed equations, we've only plotted 2 points. It might be helpful to plot more here because accuracy, in this case, is going to matter. If you just plot 2 lines on here, and you're looking for where they intersect, if your lines aren't accurate, it's not going to work well. Okay, so instead of just getting two ordered pairs, let's continue using slope. Up 1 over 3 again, up 1 over 3 again. Okay, let's get several options here.
Are
Cool?
you recording it?
Yes. Right? And in fact, if we want to go the other way too, just to even be more accurate, we certainly can, right? Slope tells us to go up 1 and right 3. That's the same as going down 1 and left 3. Down 1 and left 3. Down 1 and left 3, right? So now we have a very, very accurate line that represents y equals 1/3 x plus 1. And what is true about every single ordered pair that we've plotted here in relation to the equation? Every single ordered pair that we plotted is a what to the original equation, y equals 1/3 x plus 1. Colin? A solution to it, right? Just like all these ordered pairs were. By definition of a line, and we've talked about this before, every ordered pair will work in the first equation. We want to know which of these ordered pairs will also work
The next one.
in the second equation.
I didn't know.
Right? So let's graph this one in red here. Y equals negative 2x plus 8. We're going to start by graphing y-intercept, positive 8. And now we're going down 2 over 1. Remember this negative 2, right? Negative 2 over 1. So down 2 over 1, down 2 over 1, down 2. Oh, yeah. We've done it, right? Where these two lines intersect. Every ordered pair on the red line is a solution to the red equation, y equals negative 2x plus 8. Every ordered pair on the green line is a solution to the green equation, y equals 1/3 x plus 1. Where those two lines intersect is where the magic happens. Where those two lines intersect represents the ordered pair, the one ordered pair, because lines don't curve, it's not going to come back around and hit it again, right? The one location where those lines intersect is the one ordered pair that works in both of them, and that ordered pair is 3, 2. Okay? So the solution to that system, the one solution in the system, is x equals 3 and y equals 2. Any questions? Cool.
This is easy.
I'm glad you think so. Okay? I mean, it really isn't anything new other than understanding what a system is and why we graph them, what we're looking for, right? We've graphed equations for a long time now, several different objectives, several different power objectives, right? You've done this. But now it's looking for, okay, how do I use this to answer the question? What am I looking for? You're looking for where those lines intersect. The one value for x and y that works. And we can check it too. Plug in 2 for y equals 1/3 times 3 plus 1. 1/3 of 3 is 1. 1 plus 1 equals 2. First one checks out. 2 equals negative 2 times 3 plus 8. Negative 2 times 3 is negative 6. Plus 8 is positive 2. 3 and 2 are the solutions for x and for y. Questions? What's that?
Are yawns contagious?
They say they are. Yeah. Let's look at the next one. Again, not another one you want to try and solve mentally. You folks that prefer the guess and check method, now you're looking for two variables that work in two different equations. Guessing and checking all of a sudden became a lot more complicated. Okay? So the process for this, because they're in slope-intercept form, let's go ahead and graph them. The first one, green. Y equals 5/6 x minus 3. Our y-intercept is down at negative 3. Our slope, up 5 over 6. So it's going to put us right there. How can I get a point on the left side here? If I went up 5 and over 6 to get the point on the right, what can I do to get a point on the left? It makes me nervous only having two ordered pairs. I would like a third. Will?
Going down 5 and left 6.
Yeah. Going down and left, or going left 6 and down 5, right? That would also work there. Slope is like a staircase. You can go up, you can go down. Right? So here's our line. Every ordered pair on the green line is going to work in the green equation by definition of what graphing a line does. But we want to know which ordered pair also works in the second equation. So, graphing. Y equals 3/2 x plus 1. We plot our y-intercept, positive 1. We're going up 3 over 2, up 3 over 2, up 3 over 2. It's a good thing I went left, right? Because I'm not going to hit my green line by going up and to the right. So instead, I go down and to the left. Over 2, down 3. Over 2, down 3. Over 2, bingo. We got it. We got it. Boom. Okay? And where those lines intersect, that's the magic. That is the one ordered pair, the only one, that's going to work in both equations. We've solved the system. Okay, we've solved the system. And what ordered pair is that? -6, -8? Okay? Questions on this? I'd like you to raise your hand before you. No? Guess what you get to do in Algebra 2
What?
with solving systems of equations?
Same thing? You solve it with one.
You getting to go home.
Well, we'll be solving these with on a graph also. It's a three-part
Oh, you
series.
have to make the graph.
Your equations will have an x, a y, and a z. And because you have 3 variables, how many equations do you think we need to solve it?
10.
3.
3.
6. Who got 10?
Two variables, you need 2 equations to solve it. 3 variables, you need 3 equations to solve it. You won't learn about this till Algebra 2, but there is a third axis to the coordinate plane. It's the z-axis. Who knows what the z-axis
That's going like this
looks like?
way, right?
It's like it's going straight through, like straight out at you. It's a 3-dimensional axis.
You should teach us one day.
Well, if we get through algebra, maybe we can dabble in some algebra. I do have an Algebra 2 book in the back if anyone wants to take
Can I
it.
have that?
We'll maybe do a sign out.
It's not fair.
I could have Jeff deliver one at your doorstep.
Yeah, can you please please do that.
Okay, let's look at what else this objective has for us. Oh, well, here we go. Okay. Where do the lines on each coordinate plane intersect? What does this mean? Okay. We already identified where they intersect, but as far as the what does this mean, Rel, what would you say?
I know it's what they're on to do.
Where the lines intersect means what? But what does that mean as far as our,
Where they meet, where they're like on top of each other.
okay,
Where they could cross.
where they cross, but why do we care about that? Why is that where the magic happens? Real, I'm still kind of looking in here. Oh, Finn,
Because then it's perpendicular.
nope. Yes, that point is our solution. We care where the lines intersect because that point represents, it means where the solution is for both equations. It's the solution to the system. Where the lines intersect, that ordered pair is the solution to the system. As much fun as it is to plot points and draw lines and things like that, we're doing it for a purpose. We are looking for where those lines intersect. Every ordered pair on each individual line is a solution to that specific equation, but where they intersect, right? That is the solution to both. That is the solution to the system. Okay? So a system of equations, we can define it as multiple equations with the same values, same solutions, we'll say, for the variables. Okay? A system of equations is multiple equations. We're only going to deal with 2 equations, but it could be more. Okay? So multiple equations with the same solutions for the variables. Whatever x is in one equation, x will be the same thing in the other one. Whatever y is in one equation, y will be the same thing in the other one. Or h and n or a and b, whatever your variables are. It doesn't really make a difference. Okay? What is the solution to the system of equations to the right? We'll start with that. 2 equations have been graphed. What is our solution? Hand in the air, please. Paul. 4, 3. How'd you get that, Paul?
Because they intersect at 4.
Where they intersect, right? Where they intersect. It says write the equation of each line and show the solution works in each. Let's start with f of x. What? Function notation. Remember we said one of the purposes was to label multiple equations, multiple lines on the coordinate plane. Here's the application of that. When I say, look at the line that's going down from left. No, it's f of x, right? Look at f of x. What is the equation for f of x? Nathan.
Y equals -1/2 plus 5.
Nope. Oh yeah, it is. Sorry, I can't count. Sorry. Oh, here we go. That deserves a. There it is. Y equals -1/2 x plus 5. Nathan got that by looking at where it crosses the y-axis, right? Crosses the y-axis at +5. Down 1/2 is the slope. Okay. How about g of x? What is the equation for g of x? G of x. Colin.
G of x equals 3/2 x -3.
Good. G of x is 3/2 x minus 3. And remember, f of x is really just y, right? But by labeling it f of x, now you know which equation I'm referring to. G of x is just y. But by labeling it g of x, now you know which equation I'm referring to there. Okay? So we already got the solution before 3, which means that if we plug in 3 for y and 4 for x, it's going to work. -2 plus 5 does equal 3. Checks out. If we plug in 3 for y and 4 for x, 3/2 times 4 is 6. 6 minus 3 is 3. This checks out as well. Okay. Your homework for tomorrow, the second page, gives you 4 of them to do. Okay. You are solving each system by graphing. And then show that you verified the solution works. Show that you verified the solution works. Plug your ordered pair into each equation and show that you verified the solution works. Math packet is also due tomorrow. Khan Academy is assigned due Thursday. Conferences tonight. Big week. Valentine's Day tomorrow. That's our math, folks.